the better the secondary part of this is going to become. How we start to choose between whether or not it's going to be what we call permutation or combination style problems, whether or not order is going to matter when you're picking these things through. How do you set up this basic scenarios and stuff like that? How some of these formulas work standing on their own. Yeah?
Why is 0 factorial 1?
It's when you take 0. What's that? There is a way to do it, and I forgot how they did it. We looked that back up because it's been. I remember having to do this a couple years ago, and I forgot how you do it. I'll Google it and let you know. It's probably some stupid rule. Anyway, what a lot of this stuff boiled down to is just real basic counting principles. Can you multiply things together? Can you figure out how many different events are going on? Very simple ideas here. When we talked about yesterday the whole sandwich thing, the turkey on white, you see like the turkey, turkey on rye, rye on turkey, things like that. You're just looking at specific choices. They're not saying you can choose 4 of these, 5 different toppings, and this, that, and the other. They're just saying you have 5 toppings, pick one, and so on and so on. So they're looking at the total possibilities that are there. So if I'm looking at something where you have one event that's got 3 ways and another event that has 5 ways, what that means is that you're looking at, well, one event has 2 things that can happen. Well, you can 2 first time, you have 1 left the next time. That's why we say it's 2 times 1. Oh, excuse me, or I'm thinking 3. So I'm thinking of just the arrangements. So if I just move them around, it's just the 3 times the pot. I was looking at the wrong pot. Yeah, it's just 15. Okay, you're just picking ways that things can happen. And then in 18, it's 4, 6, 9, and 7 all multiplied together, and that's it.
15, 12.
12. Okay. Then you got in the license plates, and I know I spent a little bit of time on that in the video. What happens here if you're looking at license plates, there's 2 different scenarios that can happen. You can have repetition or non-repetition. And it's just a matter of being able to count and knowing how many things are in certain stuff. Ooh, excuse me. For example, how many letters are there?
26.
How many digits are there? 10. How many cards are in a deck?
52.
How many suits are there?
4.
4. So we're going to start using things like that. How many digits are on a number cube?
6.
We don't want to call it a die because you know what? It refers to gambling. You know why that's why they don't say you roll a pair of dice in your book? They say you take 2 number cubes. Ever notice that?
How does that refer to gambling?
It's just one of those things.
Isn't that just what it's called? You could just refer to yachts.
Rolling dice. If you're just rolling if you're rolling dice, if you say you're rolling dice, it implies gambling. But yet in textbooks, that's why they say number cubes because it doesn't say dice.
I never noticed that.
Yeah, it'll say a lot of books will say number. I think this one says both.
Where are you gonna find it? Number.
Not off the top of my head, but I've seen number cubes written a lot. Yes, ma'am.
For number 57.
I'm not even close to that one yet. Let me start. I'm working my way there. Okay. Don't worry.
Well, it's exactly like this, except it doesn't tell you how many digits and letters we use. So.
It does say. It does say. Read. What does it say?
47. To keep computer files secure, many programs require the user to enter a password. The shortest allowable passwords are typically 6 characters long and contain both numbers and letters. How many?
Okay. All right. Okay. Numbers and letters. How many letters are there?
266.
How many numbers are there?
And then you have to do that 36 power 6.
How many are there then? How many characters are there?
36 to the power 6. If they
36.
You just power 6.
Wait, oh, you have to do how many?
How many numbers are there? Stop. Everybody, wait, listen. How many letters are there?
26.
How many numbers are there?
Oh, I get it now.
How many are there? That's your characters. 36.
Because
That's
they
it.
could, so it's,
Because you're saying you have that many characters to choose from? You have 26 letters and 10 numbers.
so then we do 36 times 36 times 3.
Yeah. And then if you're with repetition, and that's with repetition, and then if it's the other way around, it's 36, 35.
Oh, I didn't do that right. I did 10 to the power 6 and just like
You get the same number.
Really?
Yeah.
I did.
So when I'm looking at this, 2 digits followed by 4 letters. You're looking at numbers first, then letters. Well, how many numbers are there? 10. So in the first one here, you're looking at, for part A, allowing repetition, you have 10 to choose from, 10 to choose from, 26, 26, 26, and 26. Whatever that is.
It is 4, 5, 6, 7.
Sure. What kind of license plate in Illinois starts with numbers first?
None.
Oh,
The
the one that's only numbers.
Yeah.
Truck plates. Truck plates.
No.
Truck plates start with numbers. Passenger cars start with letters. Oh.
And the government officials just had like,
What's that?
like the senators and all that.
No.
One,
No, because I have truck plates that are all numbers.
No, not like all numbers, but like, there's someone that has license plates and just has one.
Yeah, those are very special. They hold on to those specialty
Yeah,
plates
for,
like
like,
that
the
for,
government, right?
yeah.
Yeah.
And
Because
like,
when I went to Springfield like a month ago, we saw like 27. 27.
A lot of people do weird
My
things
mom
like
has
that.
SSL.
I don't know why, but like all my aunts and uncles have like
That's
one. It's weird.
My dad has Shark 8.
My mom has 6, 7, 7, 8, 2, 2, 2.
Now, if you're talking about
My mom has 10.
not allowing the repetition, if you have 10 in the first bunch, what's the next one?
9.
There you go.
Ooh, that's good.
And then you have,
24, 23.
And the other 2.
it's this pen that doesn't work. I changed the tip and it doesn't work.
You can change the different.
you can do a lot of stuff here.
I mean, seriously, that is so weird.
That's ridiculous.
Anyway, and then the next one, we're talking about 5 letters followed by a digit. You've got your 26 to the 5th times 10,
Yep.
26, 25, 24, 23, 22 times 10. So it shouldn't be that bad. Now, remember, when you're doing factorial, if it says 5 factorial, it's not 5! Yeah, exactly. I probably scared the hell out of that one.
When the calculator gives us an answer in scientific notation, do you want us to write the phone number out on our paper?
Scientific, to quote somebody else in this room, scientific notation is for chumps.
Yeah. But
You can leave it in exponential.
that's what I was gonna say, one of the problems told us to write our answer.
Yeah, and that's, I get it. You can left it in exponential form, it's fine.
Exponential and
Like 26 to whatever power it was.
and then you evaluate.
Because it's giving a number that doesn't spit out your calculator.
That's what I'm writing.
Without the e to the 10th or whatever it is.
But it does really wrong, everything's wrong.
When I get to that one, I know which one you're talking about. I'll show you.
And just grab everything and send something.
I hate scientific notation because I don't remember how to do it.
I don't know how to do it.
So I can do everything and send it.
Yeah, by the time we're
Permut-
7th grade.
Permutation stuff, when you're looking at these, I want to show you guys a nice little reminder that you can do this without a calculator because you might have to. Remember when you're looking at the formula, if it's n permute r, it's n factorial over n minus r factorial. So it's 5 factorial over 5 minus 2 factorial.
So it would be 120, wait,
Hold on.
What this looks like, 5, 4, 3, 2, 1 over, what's 5 minus 2? What'd you do?
should get surgery on her bunion.
What'd you do?
A bunion on the foot.
Now you have a heavy foot. Get it? Now you're
It's like,
heavy foot.
bunions are the ugliest thing.
She's having-
It's like almost ugly. It's like right here. It like sticks out.
How long you did up for?
I'm gonna have 6 degree weights. So you get this
How
really
long
big
is this
bump.
hole was in?
You can get on both sides. Yeah, it's like yes. And I didn't have to get surgery on it.
At least you won't walk around looking like a dope.
Is your bunion gone?
Yeah.
So yeah. And the denominator is just 3, 2, and 1. And I want you guys to remember when you're working on these, it's okay to do these by hand because it's just 20.
Oh, it's just great.
It is. These things drop out.
Wait, why is it? Oh, it's not minus?
No, it's 3 times 2 times 1. Yeah, it's 5 minus 2.
Yeah, the 5 minus 2 looks like.
But I want you to notice this. Look at what we have here when you have permutation. 5 commute 2. What is 5 minus 2? What your denominator?
Nine minus 4 is 5.
So what's in your denominator?
5.
So it's 9 factorial over 5 factorial. So this is really 9, 8, 7, 6. Because the 5, 4, 3, 2, 1 is going to just cancel out. It's going to simplify out over 1. 20. So no. When you get into the ones, we have to worry about distinguishable permutations in the word. What I want you to think about here is that this is going to match. These are permutations without repetition.
Yeah, I didn't see that, so I was just making sure.
When you're dealing with the ones without repetition, you're looking at, well, how many letters are there? Well, how many letters in the word jet? 3. So if I'm going to take 3 letters, and the first one I have 3 to choose from, I'm not repeating one of the letters, I'm going to the left.
2.
And then what?
1.
So isn't that just 3 factorial? Yeah. So in Florida, how many letters are there?
7.
So wouldn't that just be 7 factorial?
Yeah.
Okay. The difference between that and the secondary set there is that they're dealing with repetitive values. So if you're looking at the word puppy,
You meant to put 3 factorial in the bottom?
correct. You can actually do it with, I'm going to show you how this works a little bit cleaner than it might have done yesterday. I don't remember if I did it this way or not. If I'm looking at the word puppy, because we're worried about with repetition, how many letters are in the word puppy?
5.
5. So the 5 factorial goes in your numerator. Now, if I'm looking at the letters, I have a P, U, and a Y. P is repeated how many times?
3.
And the other ones are 1 and 1. You agree? So the rule is basically this. Take those, throw factorial next to it, and put it in the denominator.
And it's just 1.
Yeah. So it's 3 factorial, 1 factorial, 1 factorial. 1 factorial is what? And so it's unnecessary. That's why they don't put them in there. So they're just looking at putting in the denominator whatever has been repeated that many times. So this is 5 factorial over 3 factorial, which is in essence what? 20. Very good. It's just 5 times 4. I'm sorry, what's that?
Oh, because there's 5 letters in the word.
Yep.
So then you do that over how many letters are repeated.
Yeah. Take a look at what do you
You're
have?
like,
I think I understood this right, but I'm not sure. So for each different letter repeated, you need a different
Yeah.
factorial?
Yep. So if I'm looking at Alabama, look at Alabama. You have you have what? 7 letters? You have 7 letters. There are 4 A's, and everything else is repeated just once. So it's 7 over 4 factorial. 7 over 4 factorial is 7, 6, 5. 210. Well, 6 times 5 is 30. 3 times 7 is 21. Add a 0. Obviously. In Connecticut, 1 little, 2 little, 3 little letters, 4 little, 5 little, 6 little letters, 7 little, 8 little, 9 little letters, 10, 11 letters. 11 factorial.
That was
Yeah, C is 1, 2, 3, so we have 3 factorial.
N is 2.
O is once, N is 2,
T is 2.
and T is 2. Now, let me show you how this can work longhand with larger values. It's kind of cool. We have 11 factorial, so it's 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Over 3, 2, 1, 2, 1, 2, 1.
So get rid of 1, 1, 1, 2.
So I can go 3, 2, 1, 3, 2, 1. And what's 2 times 2?
2. 4. I thought you said 2 times 1. I already got it.
So my answer is going to be this right here.
Cool, dude.
It's kind of nice when you start doing some of these. When you do the combination stuff, we'll probably work on that more tomorrow. When we get into those, the denominators become a little bit messier. So there's a little bit more stuff that winds up simplifying out. Believe it or not, permutations are the ones that order matters. Okay, the order in which things happen matters. You pick the first letter, it's out. You can't take it out anymore. Okay, there's a specific order. So when you have a combination lock, the combination order matters, doesn't it?
Yes.
It should be called a permutation lock, but it's not. It's combinations means you're just mixing them all
Hey,
together.
what's your locker?
It's there. What's that?
If it is, it won't work.
It won't. I can't remember. I don't know any words that have more repeated letters than new letters.
I'm using the word kayak right now because it's the same word spelled backwards.
It's a palindrome.
So,
I was at
is
the
that spelled backwards?
Race car.
Palindrome.
I think so, yeah.
It's like palindrome, like no.
I was at the grocery store one time and my bill was like $41.14. Like, oh, it's a palindrome. The person looked at me like I was on crack. I'm like, yes, I am. And then one day my bill was 1, 2, 3, 4, 5. Yes, I spent too much money at the store. Oh, do I win a prize? And she's like, what?
Yeah, we'll get grocery stores.
That sounds college.
Yes. No offense to grocery store people. It's no offense.
You know, in seventh grade, my locker was.
So let's go into the word stuff here so you can try to decide what you're going to use. So if I'm looking at the first one, you're just selecting stereo equipment because you want to rock out and have a good time. You have 5 different receivers, 8 CD players, and 12 different speaker systems. You're just looking at the possible combinations of, you want to pick one of each of them. So it's 5 times 8 times 12. It's that straightforward. Okay? Is it 480, I believe?
55.
Yeah, 480. Pizza. When you're going to buy a pizza, you have,
This one's a palindrome.
oh, it is?
It is.
You have 7 times 11 times 6, 3 times 2. What do you get? 2772. It's almost the same upside down as well.
What? I
Yes,
cannot
ma'am.
do these correctly. Go over this again.
Oh, demanding there.
You know, Laura doesn't get very upset very often, so I'm going to go ahead and take care of that before she gets up and throws something at me, because I would have passed her.
There was an entire question that I had, and you just completely ruined it with your nonsense. Don't touch me.
Anyway, so you have 9 cheese, or 7 cheeses, 11 veggies, 6 meats, 3 crusts, 2 sausages, and a partridge in a pear tree.
No.
Well, fine, we can. You're just looking at possible scenarios.
You're trying to mess it up with the price tag.
All right. Yeah, and the price is like, yeah, whatever. So there's what? 2772 possibles. Yes, ma'am. Before you forget your question again.
I had to remember. But alright, so say that it's like 2 factorial, 3 factorial down, and everything just multiplied together versus factorial.
No, because factorial means 6 times 5 times 4 times 3 times 2 times 1. If you're taking 2 factorial times 3 factorial, 2 factorial is 2. 3 factorial is equal to 6. 2 times 6 is 12. Not anywhere close to 6 times 5 times 3 times 2. Okay, does that make sense? Just use the basic definition and you'll start to see how that will work.
Next one we already did.
The computer said, yes, does that make sense now with the 36 characters versus the other?
Yeah.
Nowadays it's even more than that because they want to throw a capital in there and they also want special character keys as well. So that's why passwords become even more and more secure because you could hack them much easier back in the day. Yes, ma'am.
It's like kind of going back to 13 or 38.
So did I.
38. That one's a good one.
Let me show you what happens here. When you do this, this is the same, this problem comes up now in 58. If you're looking at the actual pure definition of N per U R, The definition of n permute r is n factorial over n minus r factorial. If r is 0, you get n factorial over n minus 0 factorial. Which, no, what's n minus 0?
N.
N. So your numerator is n factorial, your denominator is n factorial. They're the same number, aren't they? Anything divided by itself is 1. That's why that works. And that's why 38 works. With 16 permute 0, you get 1 as well.
I didn't really know what to write for 50, so I kind of made up something.
Well, if you would have went back and looked at 38, you would have done the same thing. All you have to do is the same, you're just using the definition. Use the definition.
I did use one word. I just didn't simplify the word.
Okay. 59 is just your 24 factorial, because you just arrangements. Ringing bells, you get the 10 factorial. How many ways can they be wrong?
No, 59.
That was the weird sign.
59 is.
Yeah. Oh, that's a scientific. It's just 24 factorial. It's a giant number.
Oh, I
Why
Okay.
is it 24 times 24?
Yeah, that's what I thought it would be.
No. They're just saying that there's 24 seats with 24 students. They're just saying there's enough students to be if all the seats are being used.
Oh, okay.
In here, it would be different because we have 18 versus
I know,
35
for
because you
each-
can.
For each student, there's 24 ways.
Right.
Yeah.
Strong, square peg, square hole, not square peg, round hole.
Of course.
You're talkative today. I'm getting there. I'm still on 61.
just talked about.
No.
You just talked about.
No. I talk about ringing of the bells.
Is that supposed to like be a gift to the part? That's something else. That's how are they gonna break the bells down when they come?
I don't know. It's just how many different ways could they ring the bells?
It's like three now.
Auditions. Does anybody see that thing to the right of where it says
Yes.
play audition? It says the drama club open auditions, parts in 1-act play. How many parts are there?
6.
6 of them. So if 6 people audition, how many different ways can all 6 of them get it? Well, that's just 6 factorial. Whatever it is. Was it 720?
No, I did it wrong.
The next one is a little bit different.
720.
You have 9 people auditioning for 6 possible places. So it's 9 permute 6 because the order is going to, once you get a part, you're not going to get another part. The order is important here. Okay? So if you do that, you have 9 factorial permute, or excuse me, 9 factorial over 3 factorial if you do it longhand. So it winds up being 9, 8, 7, 6, 5, 4, all multiplied together. Some big number.
Wait, why are
Just something.
Part A is
Oh, because there are 3 persons.
a lot of numbers. Sure. Yes, ma'am.
Okay, so whenever you have like the perfect number of people for the number of spots, even if it's not like a play kind of thing, like you just do the factorial. But if there's,
Not necessarily. We haven't gotten to combination yet. There's differences.
well, just for what we've done so far.
Are we gonna
Yes.
get the combination?
And if there's,
No, not today.
and if we're sort of doing like the top 3 people or something like that, then we use for permutations.
Yes, because the order in which you go first, second, third. First place can't be in third place.
Yes.
That kind of thing. That's where those things come into play. Right.
There's multiple positions for person. To get first.
Window display. This is where third hour.
Tournament, you know.
This is where, guys, come on. This is where third hour had a lot of questions. The music store wants to display 3 identical keyboards, 2 identical trumpets, 2 identical guitars in the window. How many distinguishable displays are possible?
That's confusing.
Think about distinguishable. It should have been a dead giveaway of the word distinguishable versus the problems at the top of the page. Because up here, they talked about distinguishable permutations. Distinguishable. We go back and reread sometime.
Completely different.
How many musical instruments are there?
There's a
Total.
total of 7.
7 of them. 7 total One of them was repeated 3 times, one of them was repeated twice, and the other one was repeated twice.
I should have known.
And this is where it's not going to be 3 times 2 times 2 factorial. 7, 6, 5, 4, 3, 2, 1 over 3, 2, 1, 2, 1, 2, 1. The 2, 1, 2, 1 goes out the 4. These go out those 2. It's 7, 6, and 5. Once again, it is 210. Okay. It's the same thing in 63 because they're talking about distinguishable outcomes. Within distinguishable outcomes, you have dog show, you have 3 chihuahuas, 5 labs, 4 poodles, 3 beagles, all lined up in front of the judges. If the dogs of the same breed are considered identical. So, how many dogs are there?
There's
15. So you have 15. We know it's going to be 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Divided by
factorial of
5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2, 1, 2, 1.
Wait, it's
Oh, 3, 2, 1, 3, 2, 1. Excuse me. 3 factorial, 3 factorial. So, fractions are fun. 3, 2, 1, 3, 2, 1. Okay? 5, 5.
Can you press out that?
2, 2, 4.
I was gonna do
Why not?
this.
3 times 2 is 6.
Do the 12. Get the 4.
3 times 4 is 12.
Oh my gosh.
And then
4
you
times
just-
4 times 3,
Did we do
4
this
times
before?
12. So just 12.
I
Oh,
have-
We did this.
You just have 4 times 3.
well, this becomes 3, this becomes a 3, this becomes,
what is it?
and a 2.
Oh my god.
So you wind up with 15, 14, 13, 11, 10, 3, 2.
You said
7.
the 2.
Where's the 7?
Right there.
Right there.
At
Oh,
the
and
end.
7.
So you end up getting about 12 and a half million.
Sure. Whatever. Remember, when you get blue large ones like this, I'm just showing that you can do these by hand. You just don't want to multiply that out. That's not a whole lot of fun. Okay?
Oh, yeah, no, it's-
Guys, trust yourself that you know how to do stuff. Really, reread instructions, reread things. If it's an instruction clarification, ask. It's okay to ask about instructions. Asking how to do the problem on tests and quizzes, not good. I'm not going to tell you. You know I'm not going to tell you. You had questions, some of you guys had questions of what was going wrong with the calculator because you typed in something wrong. I said, well, if it's not coming in right, that just means it's not right.
You know what's hard with that?
Hold on. Yes, sir.
Okay, how did you get the 3 and the 2?
4 goes into 8 how many times? That sounds
Okay.
And then the
And
3 and 9.
3 goes into 9 how many times?
4